Hey everybody, welcome back. This is the second problem in the calculating with friction assignment that we're going to take a look at. And hopefully this will make as much sense as the last one, and you can always go back and kind of rewatch them as it goes. Uh, and you're welcome to come in during office hours if it doesn't make sense, and I can try and explain it even better. But here's the question. The question starts out and it says, how much force must be applied to push a 1.35 kilogram book across the desk at a constant speed if the coefficient of sliding friction is 0.30? All right, so we've got a few things that are going on here. So we can start by saying, okay, the thing that I am wanting, right, in the end is this how much force. This is the piece that I want to figure out. It tells us a few other pieces of information here. It tells us that we are applying a push to a 1.35 kilogram book, right? Now, the important thing to recognize here is that 1.35 kilograms is not a weight. It's not a force at all. In fact, this 1.35 kilograms is a mass. So we can't use this as a force. We cannot put it into our free body diagram because it's not a force. So we'll have to figure out what to do with that. And then it does have this other piece, right, which says that we're talking about this constant speed. So this is the next part. We've got a constant speed. If it's a constant speed, that means that there's no acceleration and all the forces have to be balanced in the end. And it gives us one last piece of information here, right? And that last piece of information is that we're talking about if the coefficient of sliding friction is 0.30. So, right, that's our coefficient for sliding friction. All right, so I've got some pieces in here and I need to figure this out. So to do that, I'm going to start out by drawing my free body diagram to try and make sense of this. I'm going to start out by putting my book, right, and we're putting it across a desk, but same as the floor in the last problem. So here's a book. And we can go ahead and say that this is moving kind of across a desk if we'd like. And we're going to be looking at the different forces that are involved in the book and see if we can make sense of that. Same as the last problem, right? We have the force of gravity that is pulling down, right? And that force of gravity here, I'm going to write as Fg. Because we're sitting on a desk and the book is not being pulled through the desk, nor is it being flipped up off of the desk, it means that we do have balanced forces with the book and the desk, or the gravity in the desk, which is again this force that is normal. And they're equal and opposite because this is again flat or perpendicular to this whole piece. All right, there are two other forces that we're looking at here. One of those forces is this force of the pull or push, however you want to think about that, is moving in this way. And then because it is at a constant speed, then we also have this back here going against it. We'll call this the applied, or this could be the force of the push, doesn't matter. And then I'm going to call this the force of friction. So all of these forces now look just like our last puzzle, like we didn't change anything. However, we're doing a couple things that we didn't do before. One of those things that we didn't do before is we have this coefficient of sliding friction, which means the coefficient, and I'm going to put it like with a sliding, which I'm going to use this K for kinetic, meaning that it's sliding. You would think that I might use an S for slide, but then we've also got static friction, which is the other half. That's a little bit confusing. So I'm going to use mu sub K for this kind of sliding friction. It looks like somebody's coming in, so I'm going to go ahead and pause for just a moment.
First time. The first one.
All right. So I just had somebody come in during office hours. I got a little sidetracked, but that's okay. I think we were at the point where we were talking about the coefficient of kinetic friction here. So let's go ahead and record that, what it is, as 0.30. Now there's no units on it. It's just a coefficient. So this is what I've got. What other pieces of information do I know? What is this point or 1.35 kilograms? Well, if I was going to give it a label, I would say that this label is actually the mass. It is the mass of the book. And the mass of the book here is 1.35 kilograms. Now here's the kicker. 1.35 kilograms, I can't put that on this kind of piece over here at all. But I can use the mass of the book to be able to figure out something about the force of gravity, right? Because Newton's second law actually tells us that force is equal to mass times acceleration. Oops, let's put that in as an A for the moment. F equals ma. For when it comes to weight, though, the weight or the force of gravity or the weight is equal to the mass of whatever the object is times the acceleration due to gravity. And I'm going to put that in as a G instead of an A. They're the same thing as you're looking at it, right? F equals ma, or the force of gravity equals m times the acceleration because of gravity. These are still true statements. And this Fg is the weight. So I can actually solve for the weight to be able to figure out what Fg truly is. And I can do that right now because I do know these two factors. You might not think that we know what g is, but we do, because g is the acceleration due to gravity, and that acceleration due to gravity is always 9.8 meters per second every second. That's true for all objects that get dropped, period, or all objects in Earth at all, to be honest. And so if I go ahead and I use these pieces of information to figure out what the force due to gravity is, that's pretty easy. I can do that by saying F sub g is equal to my mass, which is 1.35 kilograms. And I'm going to multiply that times 9.8 meters per second squared. Hang on, I got somebody else coming into my office hour, so I'm going to go and pause. All right, so we're back again. Thanks for your patience as I take a couple glitches. It gets me back on again. If I multiply these two things together, I've got 1.35 times 9.8. 9.8 is almost 10, so I know it's going to be close to 13 in the end, moving that decimal, but it'll be a little bit less than that. So 1.35 times 9.8 gives me that force of gravity here, or weight, is 13.23 newtons. Right, so that's what this little piece is. This is almost like an aside, like you got a piece that I'm looking at. But I can actually use that over here in the problem now to plug in some things. I can say that the force of gravity now is equal to 13.23 newtons. And if the gravity here is 13.23, then my normal force, because it's not being sucked down into the table or thrown up into the air, my normal force is also 13.23 newtons. Now, is this enough to be able to solve for how much force must be applied to push the book? Well, keeping in mind that my force of friction and my force applied are going to be equal to each other, the answer is yes. And I'm going to use this equation, which is the equation of the coefficient of friction is equal to the force of friction divided by the force that is normal. Now, recognizing that the force of friction is equal to my applied force means that if I was to resolve this, kind of change where things are in this problem, and I was to solve for the force of friction, that's going to be equal to my applied force. So I'm going to do that right now. I'm going to take this and I'm going to get the normal force and move it over to the other side. And to do that, I'm going to multiply on both sides by the normal force. This is just algebra. So I'm multiplying by the normal force on both sides. On this side, it cancels out. And what I have left, if I rework this, is that my frictional force is equal to my normal force times my coefficient of friction. And maybe I'll put this in with a little k there so we know we're talking about kinetic or sliding. Do I know these two pieces on the right-hand side? By gum, I do, right? The normal force is directly opposite what gravity is, or the weight. And we know what the coefficient of friction is because that's given up here in the problem above. So I'm going to go ahead and plug those in and say that my normal force is 13.23 newtons. Hang on, I got somebody else coming in. Give a pause here. All right, we are close. So here we've got this 13.23 newtons, and I'm going to multiply that times the coefficient of friction, which is 0.30. And this is going to get me my my frictional force, right? So what do I get from this? So times 0.3, and this walks away with a frictional force of 3.969, which is a really weird number. So I'm actually going to round this up and just say that this number right here is 4 newtons. Hang on a second. We got somebody else coming in. All right. So we are almost there. By the way, I love the fact that people are dropping in during office hours. I think that is outstanding. If you are somebody that hasn't dropped into office hours yet and you're watching these videos and you have any questions, it makes my day when people come on by for office hours, because it means that you're trying to figure it out, and we can usually sort things out within just a few minutes and off and running. So just letting you know that lots of people come in, and I'd love to see you too. All right, so we are very nearly done to this problem. We know that the force of friction, right, is this 4 newtons. But if you look up here at the top, the force of friction being 4 newtons, it means that the applied force is also going to be 4 newtons, right? And the question here says, how much force must be applied? Well, in order to make all these things be true, the force of friction being 4 newtons means that the applied force is also 4 newtons. So your force applied is going to equal to 4 newtons, and this is my final answer. Oh my goodness, so many things. The first thing over here is just an aside, right? These kind of bits was trying to figure out what the gravitational pull was in order to figure out what gravity is. And then I went through and, put together my knowns, and I used my equation here and I changed it around so that it can solve specifically being solved here for the force of friction. And I did that here, plugged in what I knew and solved it, and then put it back to the other side. But there's more here than just being able to move stuff around. You really have to understand what's going on in order to make sense of it, which is why a problem like this is pretty involved. Like, you have to recognize that the force of friction is equal to the applied force when we know that they have a constant speed. And we have to know that 1.35 kilograms is not a force, and that we're going to have to be able to figure out kind of what the force of gravity is based on that mass. So hopefully this was helpful to you, and I'll see you in the next one if you want to keep watching. Adios.